Hi, my name is Marco from LightObject. Today I'm going to show you guys how to use one of special feature from DSP controller card. And this feature should be available to most DSP controller card like our T9, X7, or Raider 6445, 6442. This feature is we call Air Assist. And you would say, hey, why do I need to use the control for the air assist? I have an air pump. What's the air pump? Let me. Yeah, I think most of you are using this kind of air pump. Well, it works, but there's some disadvantage. The first one is this is very noisy, and when the system, when you doing a laser cutting, sometimes the machine may be idle. You are trying to work out some files, right? And but the air pump will still running, and it creates so much noise, and it's so annoying. After I would say 10 to 20 minutes later, you will get so annoyed. The other thing is it will be getting very hot very soon. And then third thing, of course, electricity, because you have to keep this one on all the time. So like this one, this is 135 watt. So you use or not, it's still burning the electricity bill on you. Okay. So let me put it back first. So what do we do then? Today I'm going to introduce one of the device we call air valve or a solenoid, and then an I/O board. All right, this one is a 24 volt solenoid, and the I/O board there are two different kind of I/O board. Actually, three. This one is 5 volt, and we have a 12 volt and 24 volt. How do we select the I/O board? Well, it depends on the controller card you have. Like T9, we're using 5 volt. The Raider, we're using 24 volt. The Chosen X7, we're using 24 volt either. So let me show you how to make the connection. And then I'm going to show you how to make the connection to DSP. But let me show you how to make a connection on the solenoid first. Okay, this is a air valve. Actually, this is a solenoid too. So there's a coil built in here. When you energize the coil, it opens the valve and let the air go in one way to the other. All right. So let me show it to you how to make some connection. What I'm trying to do is I need to add a dial to the solenoid. The reason is a coil, a solenoid, when you energize it, and then when you let go the power, it will generate a reverse voltage or reverse current. If you don't put a dial to protect the circuit, it could damage your circuit board, like a DSP card or the I/O card, could be anything. So that's why I'm going to show you how to add a dial before you use it. All right, so let me open it. One of the screw over here, take it out. It's already open. Okay. Oh, actually, we need to take. Need to put it back. All right, come up. So actually, it can come up this way too. All right. Now let me show it to you. For a solenoid, there's no polarity, so you can power up either way. Like let me set up my power supply to 24. Actually, it could power up, it could get energized from 12 or whatever, close to, it doesn't have to be 24, but I will prefer to use proper voltage. All right. Now let's say positive on the left, negative on the right. You see that it's working. Or the other way, same thing. The only difference is there's a LED indicator. If you did properly, the LED light on. If you do opposite, it still work. The solenoid still work, but the LED indicator will not be on. You see that? However, pay attention. Now it's energized, right? When I let go the power, you see the flash on the LED? Now let's do it again. I power up, you hear the clicking, right? Now on, nothing happened. The LED didn't light up, but when I let go, boom, you see the lights, the LED lights kind of flash for a tiny second. This is the power gaining from the coil. When you release the power, the coil kind of generate opposite current and voltage and drive the LED. All right. So before we are doing so, we know that the right side is a proper way to do it. Right side is a positive, left side is negative because the LED is on. So we are following this pattern. So I'm going to add a dial. So you will say, which one should I go? And I will show it to you. But before we install it, let's check the dial first. And I'm using 1N4001 in this case, all right? And I select it to a dial. And I put one of the probe to the left, one of the probe to the right. It didn't do anything. It should be open circuit light. However, when I move the other way, like here, positive to the other side, you will see the reading close to 400 something or 500 something. Let's say I got another one, just for testing. You see that it's still running around 400 something, which is which means the dial is good to go. All right. So so you will ask, which way should I go? And oh, by the way, there's a straight line. That means this is the cathode of the dial. And then the other side is anode. Anode means positive. Cathode is negative. So we put a negative, the straight line, on the positive terminal, not the other way. If you put the positive on positive power and then negative to negative, it will blow the dial. So we have to do opposite. All right. Let me get the soldering iron ready. Okay. I'm going to put the dial over here. So we need to put a little bit solder before we iron on it. Come on. Okay. And then we put a little bit iron on top first. And negative. Remember, when you do iron on a dial, you don't want to heat it up too long because a dial could get damaged if you put the soldering iron over the lid too long. So try to keep it less than I would say 5 seconds. All right. So after done, then we double check it. And same thing. This one, remember this time we put a priority on the solenoid. Make sure this is on positive. This is for negative power. See that? It's working. You don't see the smoke coming out, that means it's working. Cool? Okay, now we are going to put 2 wire. Again, before we make the connection, we want to get some solid on top of the copper. Cool. Okay. Remember, red now on the right side. Okay, and the other side. I'll do a quicker way. I get used to this one. All right, pretty much done, and then put it back to the cover. Where's my screw? Oh, you don't want to block the air hole, so let's take it out. Turn around, do it this way. And done. All right, the next thing we need to do is to pick up a connector for these 2 inlets and outlets. All right, so we need to get the Fastnet connector. Let me see which one we should use. I have SPC 8-02. I think that would be the best fit. This is for 8 mm high pressure pneumatic tubing. So we put one over here and put one on the other side. Good thing for this is we call Fastnet. All right, this is 8 mm. You see that when you put the tube in, boom, it will lock up. No matter how hard you try to pull out, it won't come out, right? And it's air sealed. So how do I get it back? Well, simple. Just remember to release the air first, and then you press the blue cap in, press in, and now you can pull out. Cool. Okay, for the output, I think I would prefer to use the 6-02 because the reason is this air hose, the output is going to connect the laser head, right? And the laser head, in order to reach the laser head, you have to pull the cable from the back of the machine all the way through the cable carrier. And the cable carrier is going running all the time. So you don't want to use a too big air hose. You want to use smaller one, like a 602. So I'm going to put different size. The 8 millimeter on the input, and then the 6 millimeter on the output side. This is how we install on our machine. Nana. This time I prepare myself well. I have so many different color erase pen to show you guys the diagram. All right, let me draw the DSP controller card first. So let's say this is the DSP controller board. And then we need a laser power supply. No, not laser power supply, I'm sorry, the DC power supply. This is DC 24 volt power supply. And then for the T9, because for T9 controller board, the output signal is 5 volt in addition to the operating voltage 24 volts. So you need two DC power supply to work, which is another DC power supply, DC 5 volt. This one is, we use it for the SSR to control the main power for the laser machine. The DSP controller card, it doesn't need 5 volt, but it needs 24 volt. So let me put it right here, 24 volt. So we give a power. Let me see, use the other wire. The power from the DC 24 volt. Okay, and now we get a I/O board over here. The I/O board built in a relay. As I mentioned before, there are 3 different boards that we have installed, and one is 5 volt, one is a 12 volt, one is a 24 volt. It depends which DSP controller card you have in your system. But for this one is T9. T9, the operating voltage is 24 volt, but the signal, like I don't care, this is a PWM for laser or the output right here, output 1, output 2. The output is 5 volt signal, okay? So we have to pick up a 5 volt I/O board. That said, I need to get power from the DC 5 volt. Maybe, you know what? Let me use a green to represent the ground better. Okay, and then there's another green for the DC. And this is ground, 24 volt ground. And this is 5 volt ground also. Okay. And then let me draw the solenoid. The solenoid, let me make it right here. It's a coil. And then with a dial protection. The dial protection is like this. The one I just installed. And this is 24 volt. Okay. So for the I/O, there's a relay. That means there's like a switch. All right, this is the common COM, and this one we call normally NO, normally open. So how do we connect it? Now we are pretty much ready. We got power for the I/O, and then when you get operating voltage 5 volt here for the I/O board, and this I/O board take 5 volt as a signal. So this must be an input right here. This is input, and this is a 5 volt input too. All right. For the T9, the out one is the signal for the air blower. So I'm going to connect a wire from this terminal to the output. This is air assist. This is the air assist. Out one is for air assist. All right, and this is the input signal for the I/O board. Now we got signal, we got operating voltage. That means the I/O board is ready, right? And there's a relay here. So let me just draw something easy to understand. So there's a coil for this relay. Okay, let me put a dash line. This is the relay. We got a common braid, and we got normally open braid, okay? So how do we connect it? Well, the ground, we connect one of terminal from the DC power supply to one of the pin of the solenoid, the air solenoid. And then the other part, the other end, the power, we go from here, jump over, go up, and go to right here. Then the common, I should go over here. The common will go wire to go over here, cross over to right here. You see that there's a complete loop. The DC power supply 24 volt is coming to the common, but this relay, because the I/O didn't get the signal yet, so this is an open contact. When it's open contact, there's no power, so the solenoid is not energized. But once there's a signal to the I/O, this one will change the stage, close contact. So the power will power up the solenoid and let the air out. This is, let me see, anything I missed here, it should be complete. Yes, it's complete. Okay, this is the actual connection. If you can see, this is the out one. This is the output signal from the DSP card that connect to the I/O board input port. And there's another wire I forget to mention. This is a ground from 5 volt ground. So we need to have a common ground. That's why I need to connect this one to the common ground on the 5 volt DC power supply. Without this wire, the I/O board will not be taking any signal, because this is like an open loop. You need to close the loop, make a closed loop circuit, and that's why we need to have a common ground wire. Okay, this is the T9 menu. There's a button called name blow. So when I click it, it will energize the air hole, the air valve, the solenoid. Now let me try it. Now I click it. See the air hole, the air flow. If I stop it, now I stop it, all right? And then when I click again, so it's running properly. This is how it's supposed to work. And let me run a simple cut. Okay, the system is ready, idle, but you won't see the air is floating because the job's not ready, not running. See, if I'm moving the gantry, any direction, any movement, it won't trigger the airflow until I move to the job location and set it up and start right here. Now watch and pay attention to airflow. Now I'm going to start it. You hear the air? Is it how tiny the air with the constant flow forward? Then let's see how precise it is. Ta-da! With the air blower, the high pressure from the compressor, it cut better because the air is very consistent and controllable. By increasing the air pressure, there are a couple advantages. First thing, it helps to cut faster because, for example, I remember when I tried to cut half-inch MDF, when I was using the air pump, I could reach roughly 4 mm per second with 130 watt laser tube. But when I use 40 to 50 psi air compressor, the cutting speed I could reach is 9 mm per second, which is almost double. All right. But for a plywood like this, less than quarter inch, you won't gain too much cutting power. But good thing is it will be very clean, and also you will see that it's in brown color. It's not in dark charcoal, so you get less charring effect. See that? You won't see too much. This is from the driving board, right? But over here, you don't see too much charring or charcoal coming out from the cut. This is the advantage to have a higher pressure. The reason is because in the air, 70% nitrogen, and then I would say 8% or less is oxygen. The nitrogen actually help to release or to minimize the charring problem. So when you use a higher pressure air, that means you get higher pressure nitrogen. That will help to minimize the charring problem. All right. Okay, this is all for today, and I hope you guys enjoy, and hopefully it helped you to understand what an air valve can do. And today, this example that I done was based on the T9 controller card. Because as I said, T9, there are two different voltage involved, 24 volt and 5 volt. 5 volts for the control signal and 24 volt is for the operating voltage. For radar controller card and for X7 chosen, AWC 708, they are a little bit different. The output signal is 24 volt, so you can skip the 5 volt DC power supply, and you can. But in that matter, you have to use 24 volt I/O port instead of the 5 volt I/O port. To avoid this confusion, I'm going to make a drawing for these two different kind of controller card, and I will post it on our support forum in next couple of days. All right. So if you find that it is useful for your application, feel free to come to our support forum and download it and give me a like. All right. Thank you for watching.